Hi everyone and welcome to week 5. My name is Brooke and today I will be presenting on the topic of feedback loops and adaptability. I wish to explain the difference between both positive and negative feedback loops and how they function together to create a complex adaptive system. Feedback is the information gained about a reaction that occurs within a system. This reaction will allow for a modification to occur. Therefore, feedback loops can be defined as the process where a change in a system sets off a reaction which will generate a certain type of result. Adaptive systems function through the use of feedbacks, using both inputs and outputs that can either cause or is caused by a certain event. When a feedback loop occurs, the system's output signal is fed back or is used to change the input signal. There are two types of feedback loops, positive feedbacks and negative feedbacks. To put it in simple terms, a positive feedback enhances the system and reinforces change, whilst a negative feedback system will dampen it and resist change. Both types of feedback loops can create chaos and unexpected complexities that often result in a strange, beautiful, and unexpected pattern we see in the evolution of a complex adaptive system. There are always multiple feedback loops in a system, all connected and influenced by each other to show a resilience of the system. Feedback loops can be seen in many different types of complex adaptive systems, including economic systems such as the law of supply and demand, ecological systems such as predator-prey dynamics, and ourselves as human beings are full of feedback loops that regulate our temperature or clot our blood. When a complicated adaptive system with multiple feedback loops is disturbed slightly, the balance of negative and positive feedback loops seem to counteract the disturbance. This restores a system or the system will adapt. When a system is impacted by a major or unpredicted event, such as a natural disaster or an economic downturn, feedback loops attempt to reconcile the system. Positive feedbacks strive to amplify this change. This could either result in the extinction or a rescue of a complex system. Negative feedback loops tend to produce stability, or a so-called balance, dampening the effects of any change to the inputs. On occasion, negative feedback can be known as homeostasis, which is the state of equilibrium that can regulate various systems. The oscillation of predator and prey relationships is an example of negative feedback systems that can regulate itself. In America's Yellowstone National Park, there is a negative feedback loop between a wolf, the predator, and to an elk, its prey. If by some event the elk population decreases, then the wolves will rapidly die off, reducing their populations. With less predators present in the system, the population of the prey will increase dramatically, and due to an increase in food, so will the predator population. This negative feedback loop regulates the populations of both the wolf and the elk within the system, creating a balance. This cycle is continuous and self-organizes to preserve both of the species. A positive feedback loop occurs when change is reinforced, producing instability, chaos, growth, and creative destruction. In our example of Yellowstone, positive feedback loops are seen in the population of the elk. In Yellowstone National Park, wolves were hunted to extinction and were not present in the park for over 70 years. They were reintroduced back into the park in 1955. During the absence of the wolf, which is the predator, the elk or the prey population flourished within this change. Without the presence of a predator, the population increased dramatically, creating a positive feedback loop of growth. Landowners in Yellowstone began to cultivate elk and convert acres of property into conservation sites, increasing habitat for the elk, as well as banning hunting to secure population growth. But as this is a complicated adaptive system, the existing feedback loops began to reorganize themselves, attempting to correct or adapt to the event. Negative feedback trying to stabilize the system, whilst positive will amplify the event and move the system forward. As the elk population increased, so did the need for food. This resulted in overgrazing and the need for the system to regulate itself. As the elk consumed all the vegetation, they began to starve, reducing their population back down and allowing for the growth of new vegetation. However, as the population had grown to such a large number, the vegetation could not keep up with the increased rate of elks. Therefore, it wasn't until the reintroduction of wolves did the system fully recover. Government bodies have also enforced regulations within the park to help protect the environment. This acts to dampen the feedbacks within the system. For example, they made the decision of reintroducing wolves back into Yellowstone to control the elk population. Negative and positive feedback loops are complex and are constantly changing to adapt to the events, creating an existence of both order and of chaos. Feedback loops will either improve and adapt a system, or it will break it. Thank you for your time, and I hope you enjoyed the presentation.